Okay, we have an alternating series. So if we want to find out if this converges or diverges, our first intuition would probably tell us to do the alternating series test. So let's go ahead and do that. If we do the alternating series test, we want to check if the limit as n approaches infinity equals 0 of b sub n. B sub n is the portion without the alternating part, which is this. This causes alternation. We just look at b sub n. And we check if this equals 0, and we check if b sub n is always decreasing. If b sub n is decreasing by virtue of its derivative being negative, or you could also check by looking at b sub n plus 1, comparing that to b sub n. So we look at both of these. Let's check first, and if both are matched, we can say that it converges. So let's check if the limit as n approaches infinity of the cosine of 1 over n squared actually equals 0. So what happens when we plug infinity into this denominator? We obliterate this 1, and that becomes a 0. Cosine of 0 equals 1. 1 is not equal to 0. That means that we failed in our first trial. We don't even need to check anymore if it decreases or not. The alternating series test failed. That means it's inconclusive. That doesn't mean it diverges. It means it's inconclusive, and you have to do some other test. So we are inconclusive at the moment. That means we have to try another test and just think on our feet. What would you do? I would do a divergence test, because that's simple. That's very easy. That just says take the limit as n approaches infinity of the entire thing, and if that is not equal to 0, if it is anything besides 0, then you diverge. And then you diverge. So let's find out what happens when we take the limit as n approaches infinity of the entire thing. So that's going to be negative 1 to the n cosine of 1 over n squared. We plug infinity into this, and we plug infinity into this. We already know what's going to happen with this one. This one becomes 1. We just found out when we plug infinity. But what happens when we plug infinity into this? It's just going to keep alternating. It's just going to go from negative 1 to 1 to negative 1 to 1 to, depending on whether our integer is even or odd. Infinity itself is neither even or odd. It just indicates that we're going to keep alternating forever and ever. So it's never going to be 0, certainly. So that's a problem. And, well, it's not a problem. That's our solution. That's telling us that it diverges. It diverges because it's not 0. It's a problem in the sense that we tend to I like when it converges. So this diverges because it wasn't equal to 0.